question 380, insert, delete, get random at constant time complexity from LeetCode. So the question is asking us to implement a randomized set class. So this shows this is a design question. And this class, it's supposed to insert, delete, and get random at constant time complexity. So when we are talking about constant time complexity for insert and delete, the first thing that comes to my mind is either hash map or set. And we can use that to insert at constant time complexity and delete a value from the hash map in constant time complexity as well. And the tricky part is going to be the get random, that we need to have our like values from the hash map in somewhere that we can get a random of like value from it when we call this function. So this is when we need to decide on how we are going to do that. Let's jump to the code and see how we can solve this problem. As I mentioned, we can insert and delete or remove in constant time complexity from a hash map. So this is a randomized set class that we have here. We are going to implement three functions, one for insert, one for delete, and one for random. And what we need here for insert and delete is a hash map that we can insert in O1 and delete in O1 as well. But we should think ahead of time for the get random as well, because in the hash map, if we use the get random over the keys, we need to convert it to a list first, and then we can get random, which is going to be ON, which is going to be linear time complexity, and we don't want that. So from the beginning, we are going to define a list too, which we call it the store, and we store every single value that we are going to put in the hash map. We are going to put it in the store as well. So let's do that. So in insert, what we are going to do, we are going to check if the value does not exist in the hash map. We are going to add the value as the key in the hash map, and the value of this item that is being added to the hash map is going to be the length of the store, and we are going to append that value in the store as well. So let's say why we need to use length of the store as the value of this key in the hash map, because this way we can store the index of that value in the list. So when we need to call this value, we just need to call the index. We know the index, and we can call that. So let's go through this example and see how we can do it. At the beginning, we need to define the class, and after defining the class, we are going to have an empty list and empty dictionary, and then we are going to insert one in the dictionary. So for inserting one in the dictionary, as I mentioned, we are going to insert the value as value of the dictionary and the length of the store as the key. As you see, the list is empty, so the length of the store is going to be 0, so we store value 1 with as a key and 0 as the value, and we insert 1 in the list as well. Now we need to insert 2. The same thing will happen, but this time, because the length of the list is not empty and it's 1, so we are going to have value 1 as the value of this item in the dictionary, and the list is going to be 1 and 2. And then we insert 3 and we insert 4, and as you see here, this is the outcome of the inserting value 1, 2, 3, 4 to the hash map and to the list. Now we need to remove 2 from the hash map, and this is where it gets tricky. As you see here, if we have we check if we have value 2 in the hash map, which is going to be constant. We check, and if we have it, we need to remove this value from the dictionary. It's 2, so we need to remove this value from the dictionary, this one. But it's not easy to delete it from here because we need to iterate over the list and find two and then remove it. And we don't want that. For avoid doing that, we know that we have stored the index of the value 2 in the dictionary, which is index 1. As you see, 2 is located at index 1. What we are going to do, we are going to, and we know that in the list, for removing an item is going to be linear time complexity, but we are going to do it in constant. And the only option that we have to remove an item from a list in constant time complexity, we know it's .pop. This is the function that we can use to remove an item from a list in constant time complexity. But pop is going to remove the last item always. So we cannot remove 4 instead of 2. What we need to do, we need to replace these two or switch these two. So we have 4 here and 2 there. Doing that, it will cause a problem in the hash map as well, because if we put 4 here and 2 there, so now 4 index is not 3 anymore and it's gonna be 1. And this is where we are going to handle this problem. So what we are going to do, we are going to get the value that we have at the end of the list. This way we are going to get value 4. So we have 4 here. Now we need to get the index of the value that we are going to remove. The index of that value is 1. Now we need to update the value of the 4 to the index that we got. So now 4 is going to be 1 instead of 3. And then we need to replace the value that we have here. Let me do this. So now we need to replace the value that we have at index 2 with the last value that we had here. So we're going to put 4 here. And finally, what we need to do, it doesn't matter what we have at the end, we know we can remove that from the list. And also we are going to remove the value from the dictionary as well. And we are going to do this all in constant time complexity, which is O1. So let's iterate through this, and after removing this, we are going to insert 2. So now you know when we insert 2, it's not going to be at the previous location that it was. It's going to have a new index, which is going to be 3. And now we are going to get a random value here, which is going to be, for example, 3. And the way that we do that is because we have this list here, which we have thought about that from the beginning. Now the random.choice time complexity is O1. And because we have list, if it wasn't list, we had to convert this to list and then run the .choice over it. But because we have a list, the time complexity is going to be O1. And then for deleting, we have to go through the same thing. As I mentioned, we are going to find the value 1 and then put it at the end, and then we were going to update the index and so on. And if we are looking for example, for removing value 1, because we have already removed that, like or if we want to insert value 1, if we have it in the list, it is going to return false. Thank you.